Look at this image. Every single light you see represents humanity's desperate addiction to energy. We burn coal, split atoms, dam rivers, and cover deserts with solar panels, all to keep those lights on. Now, what if I told you that just 25 tons of moon dust could power the entire United States for a year? Not moon dust exactly, something in the moon dust. Something so rare on Earth that it costs $30,000 per gram, but so common on the moon that there's enough to power human civilization for 10,000 years. It's called helium-3, and right now, as you're watching this, there are 7 different countries planning missions to mine it. Not study it, not sample it, mine it. China has literally said, and I quote, "Helium-3 will solve humanity's energy needs." They've already landed on the far side of the moon. Twice. NASA's going back with the Artemis program. Not for science, not for the prestige, for resources. SpaceX, Blue Origin, and a half dozen other companies are building lunar landers right now. Oh, you thought the billionaire space race was about tourism? That's adorable. It's about controlling an energy source worth $500 billion per ton that could make oil look like the energy equivalent of a AA battery. And here's the kicker. Whoever gets there first doesn't just win the energy lottery, they potentially control the future of human civilization. Because when you control the energy, you control everything. So, buckle up, future moon colonists. We're about to explore why that boring gray rock in the sky is about to become the most valuable real estate in the solar system, why your grandchildren might work in lunar mines, and why the next world war might not be fought on Earth at all. Welcome to the Helium-3 Gold Rush. Except, it's not gold, it's better.
Let me take you back to 1969. Neil Armstrong just took his giant leap for mankind. Buzz Aldrin is trying not to trip over his own feet in 1/6 gravity, and they're collecting what basically amounts to the world's most expensive dirt samples. $25 billion spent, that's $180 billion in today's money, to bring back 47 pounds of rocks. That's $3.8 billion per pound, making it literally the most expensive material ever transported by humans. What'd you bring me from your trip? Rocks. Rocks? Very expensive rocks. But here's the thing. Those rocks were about to reveal something nobody expected. Fast forward to 1985. Scientists are still studying Apollo samples because, well, when something costs $3.8 billion per pound, you study the hell out of it. A team at the University of Wisconsin is analyzing the solar wind implantation in lunar regolith, which is fancy talk for stuff the sun shot at moon dirt. They discover something weird. The moon's soil contains helium-3. Now you might be thinking, so what? Helium is for balloons. Oh, sweet summer child. Helium-3 isn't for balloons. Helium-3 is the holy grail of nuclear fusion. Let me explain why scientists literally jumped out of their chairs when they found this. What the hell is helium-3? Regular helium, helium-4, has 2 protons and 2 neutrons. It's stable, boring, makes your voice squeaky. Party trick material. Helium-3 has 2 protons and only 1 neutron. That missing neutron, that's not a bug, it's a feature. A multi-trillion-dollar feature. Here's why. When you fuse helium-3 with deuterium, heavy hydrogen, you get regular helium-4, a proton, 18.3 MeV of energy, and here's the important part. No neutron radiation. What's the big deal about no neutrons? Oh, nothing. Just that neutron radiation is what makes nuclear reactors deadly, requires massive shielding, and creates radioactive waste that stays dangerous for thousands of years. But sure, no big deal. Traditional nuclear fission, what we use now, creates radioactive waste that we literally don't know what to do with. We're basically just burying it and hoping future generations figure it out. Traditional fusion, deuterium-tritium, still produces neutron radiation, requiring massive shielding and creating some radioactive waste. Helium-3 fusion? Clean. No radioactive waste, no neutron radiation, no meltdowns, no Chernobyl, no Fukushima. It's nuclear power with all the benefits and none of the, oh God, we irradiated half of Europe, downsides. Why don't we have helium-3 on Earth? Great question. The answer involves the sun being a jerk and Earth having a magnetic field. The sun constantly shoots out solar wind, a stream of charged particles, including helium-3. Earth's magnetic field acts like a shield, deflecting most of these particles away. It's great for not dying from radiation, less great for collecting fusion fuel. The moon? No magnetic field, no atmosphere. For 4.5 billion years, it's been sitting there getting pelted with helium-3 like a cosmic dartboard. Earth. My magnetic field protects me from radiation. The moon. Cool. I'll just be over here collecting fusion fuel worth $500 billion per ton. Earth. Wait, what? The result? The moon's surface contains an estimated 1 million tons of helium-3. Earth's total supply? About 300 kilograms, and most of that comes from nuclear decay, because of course it does.
The energy potential. Let's talk numbers, because the numbers are insane. 1 ton of helium-3 could provide the same amount of energy as 50 million barrels of oil, 10 million tons of coal, the entire U.S. electrical grid for 2 weeks. 25 tons of helium-3 could power the United States for an entire year. 100 tons could power the entire world for a year. The moon has 1 million tons. That's 10,000 years of global energy. On the moon, right now, just sitting there. Meanwhile, we're down here fighting wars over oil, destroying the planet with coal, and arguing about wind turbines killing birds. The solution is literally hanging in the sky every night, and we're like, nah, too hard. The Chinese wake-up call. For about 20 years after the helium-3 discovery, Western governments did approximately nothing about it. Some academic papers, a few conferences, lots of wouldn't it be nice conversations. Then, China entered the chat. 2002, Chinese scientists published papers specifically about helium-3 mining. 2003, China launches its first crewed space mission. 2007, China launches Chang'e-1 to map the moon. 2013, China lands on Chang'e-3 on the moon. 2019, China lands on the far side of the moon, first ever. 2020, China brings back lunar samples, first in 44 years. But here's the important part. Ouyang Wang, chief scientist of China's lunar program, said this: each year, 3 space shuttle missions could bring enough helium-3 to satisfy all human energy needs. Not could theoretically, not might possibly. He said it like it's a business plan. The West? Mining the moon? That's science fiction. China? Hold my Tsingtao beer. And suddenly, everyone remembered the moon exists. The sample analysis that changed everything. When China's Chang'e-5 brought back lunar samples in 2020, they found something interesting. The helium-3 concentrations were higher than Apollo samples suggested. Why? Because Chang'e-5 landed in Oceanus Procellarum, a younger region with more titanium-rich minerals. These minerals are better at trapping helium-3. The estimates went from there's a lot to there's more than a lot. Some regions might have 20 to 30 parts per billion helium-3. That sounds tiny, but when you're talking about billions of tons of regolith, it adds up fast. It's like finding out your backyard doesn't just have oil under it, but premium, light sweet crude that also makes coffee and does your taxes.
All right, let's talk about fusion power, the technology that's been 20 years away since 1950. It's like the Duke Nukem Forever of energy production, always coming soon, never actually arriving. But here's the thing, we actually achieved fusion recently, like for real this time. December 2022, the National Ignition Facility achieved fusion ignition. They got more energy out than they put in. Took us long enough, only 70 years of trying. We did it! We achieved fusion! Great! When can we power cities with it? Oh, probably another 20 years. Why is fusion so damn hard? Imagine trying to recreate the sun on Earth, but without the sun's massive gravity to hold everything in place. That's fusion. The sun's core, temperature, 15 million degrees Celsius. Pressure, 265 billion bar. Gravity holds everything in place naturally. Our fusion reactors, temperature, 100 plus million degrees, hotter than the sun. Pressure, a few atmospheres. Gravity, LOL, what gravity? We literally have to make things hotter than the sun's core because we don't have the sun's pressure. It's like trying to cook a turkey at 5,000 degrees for 3 seconds instead of 350 degrees for 3 hours. The main approaches: magnetic confinement, tokamaks. Imagine a giant donut filled with plasma hotter than the sun, contained by magnetic fields so strong they could lift an aircraft carrier. Problems? Plasma is unstable. Imagine trying to hold Jell-O with rubber bands. Magnets need cooling to minus 269 degrees C while containing 100 million degree plasma. One tiny imperfection and the plasma touches the walls and no more reactor. So you're telling me we need to contain something 7 times hotter than the sun using magnets that need to be colder than outer space? Yes. And this seemed like a good idea? Look, we were optimistic in the 1950s, okay? Inertial confinement, laser fusion. Fire 192 laser beams at a target the size of a peppercorn, compressing it to 100 times the density of lead in a billionth of a second. Problems? Costs $500,000 per shot, can only fire once every few hours. The target needs to be perfectly spherical to 99.999% accuracy. How precise does it need to be? Imagine shooting 192 bullets at a flying peppercorn and having them all hit at exactly the same nanosecond. That sounds impossible. Welcome to Fusion Research. Enter helium-3, the cheat code. Now here's why helium-3 changes everything. The reaction is helium-3 plus deuterium equals helium-4 plus a proton plus 18.3 mega MV. Advantages? Lower ignition temperature, only needs 100 million degrees instead of 150 million, bargain. No neutron radiation, the reaction products are charged particles. Direct energy conversion, moving charged particles equals electricity, and no radioactive waste. The products are regular helium and hydrogen. With traditional DT fusion, 80% of the energy comes out as neutrons, which damage the reactor walls, create radioactive waste, can't be directly converted to electricity, and require massive shielding. So instead of fusion to heat to steam to turbine to electricity, we get fusion to electricity. That's it? That's it. Why aren't we doing this? Oh right, all the helium-3 is on the moon. Minor detail. The reactor designs. Several reactors could use helium-3. The FRC, Field Reverse Configuration, Helion Energy is building these. They create spinning plasma donuts that merge together. It's like fusion Beyblades. Status? Actually working, achieve 100 million degrees, planning commercial reactor by 2028. 2028, so 20 years away in fusion time. The IEC, Inertial Electrostatic Confinement. Use electric fields instead of magnetic fields. Simpler, smaller, could fit on spacecraft. Status, works in labs, needs helium-3 to be practical.
The dense plasma focus. Basically lightning in a bottle, but the lightning is fusion.
Status? LPP fusion claims they're close. They've been close for a decade. How much helium-3 do we actually need? Let's do the math. Global electricity consumption, 25,000 terawatt-hours per year. 1 ton of helium-3 in fusion is about 100 terawatt-hours. So we need 250 tons per year for all global electricity. The moon has 1 million tons. That's 4,000 years of global electricity from the moon, if we used only helium-3. But wait, transportation costs. A SpaceX Starship can carry 150 tons to orbit. But the moon is far. It's 3 days away. We went there with 1960s technology. Your phone has more computing power than all of NASA in 1969. The current experiments. Right now, several organizations are working on helium-3 fusion. University of Wisconsin-Madison built an experimental helium-3 reactor. It works at a massive energy loss. Claims they'll have commercial helium-3 fusion by 2028. They've raised $500 million. Chinese Academy of Sciences, building a helium-3 fusion test reactor. Timeline classified. The technology is almost there. We just need the fuel. And the fuel is on the moon. Which brings us to the trillion-dollar question, how do we get it?
So we need to mine the moon. How hard could it be? We've been mining Earth for thousands of years. Just do the same thing, but, in space. On a world with no air. In 1/6 gravity. With 14 day nights where temperatures hit negative 173 degrees Celsius. While wearing a spacesuit that costs $12 million. It's just like mining on Earth. Except everything that makes mining possible doesn't exist. Details. Let's talk about the absolutely insane challenges of mining moon dust for invisible gas. Challenge number 1. Helium-3 isn't in veins like gold. It's not in deposits like oil. It's embedded in the lunar regolith at concentrations of 10 to 20 parts per billion. To get 1 ton of helium-3, you need to process 100 million tons of lunar soil. That's like sifting through 100 Empire State Buildings worth of dirt to find enough gold to fill a bathtub. We need to process 100 million tons of moon dirt. To get what? 100 tons of helium-3? No, 1 ton. I'm going back to Earth. Challenge number 2, the extraction process. Here's how you extract helium-3 from lunar soil. Step 1, scoop up regolith, moon dust. Step 2, heat it to 600 to 700 degrees Celsius. Step 3, the helium-3 outgases. Step 4, capture the gas. Step 5, separate helium-3 from other gases. Step 6, compress and store it. Step 7, try not to die. Sounds simple. Here's what you need. Excavators that work in 1/6 gravity. Furnaces that work in a vacuum. Gas capture systems that don't leak in space. Separation systems that work at negative 173 degrees Celsius, lunar night. Storage systems that can handle rocket launches. Power for all of this. Solar doesn't work during 14-day nights. Just heat moon dust to 700 degrees Celsius in a vacuum at negative 173 degrees Celsius ambient temperature using solar power during a 14-day night. Easy.
Challenge number 3. The dust will kill you. Lunar regolith isn't like Earth's sand. It's never been weathered by wind or water, so it's sharp, like microscopically sharp, like will destroy your lungs if you breathe it sharp. During Apollo missions, moon dust destroyed seals, clogged mechanisms, caused lunar hay fever in astronauts, and ate through 3 layers of Kevlar-like material on spacesuits. Apollo 17 astronaut Harrison Schmitt said moon dust smells like spent gunpowder and made him sneeze for days. How was your moon mission? Great. I'm allergic to the moon. Now imagine running industrial mining equipment in this stuff 24/7. It's like trying to run a factory inside a sandblaster filled with microscopic knives. Challenge number 4, the power problem. Mining operations need power, lots of power. On Earth, we use diesel generators or connect to the grid. On the moon, option 1, solar panels. Pro, sunlight is intense. Con, lunar night lasts 14 Earth days. Con, dust covers panels, reducing efficiency. Option 2, nuclear reactors. Pro, works during lunar night. Con, launching nuclear reactors on rockets. What could go wrong? Con, cooling in a vacuum is challenging. Option 3, fuel cells. Pro, reliable. Con, where do you get the hydrogen? Oh right, from water, which is also rare on the moon. We need power to mine helium-3. Use helium-3 fusion. We need helium-3 for that. Then mine it. We need power for that. Solar panels it is.
Challenge number 5, the human problem. Humans on the moon face radiation, no magnetic field, no atmosphere, micrometeorite impacts, space bullets, bone loss, 1/6 gravity, psychological issues, ever spend 6 months in a place where going outside kills you? Communication delay, 1.3 seconds each way. Try having a phone conversation with that. Cost to keep one human alive on the moon? $1 million per day. Cost of a mining robot? $10 million total. Humans are like, we're essential for complex problem solving. Robots are like, we don't need air, food, water, sleep, or therapy. Humans are like, Robots are like, beep boop, you're fired. The actual mining plans. Despite all this, several organizations have real plans. NASA's ISRU, in situ resource utilization. Plan, start small, mine water ice first, then expand to helium-3. Timeline, 2028 demonstration mission. Reality, probably 2035. China's lunar mining plan. Plan, fully automated mining base by 2030. Timeline, they actually might do it. Secret weapon, not telling anyone what they're doing until it's done. Interloon, private company, founded by Apollo 17 astronaut Harrison Schmitt. Plan, small-scale helium-3 extraction by 2030. Funding, $15 million. That'll buy you maybe half a lunar shovel. Moon Express, plan, robotic mining missions. Status, has launch contracts, no actual hardware. Reality check, their website hasn't been updated since 2020. We're going to mine the moon. When? Soon, TM. The numbers game. Let's say we actually build a lunar mining operation. What does it take to be profitable? Costs? Development? 10 to 20 billion. Infrastructure? 50 to 100 billion. Operations? $1 billion a year. Transportation? $100 million per ton. Returned. Revenue? Helium-3 price. $500 billion per ton if fusion works. Break even? 1 ton returned. Profit on ton number 2? $499.9 billion. Yeah, those margins are insane. It's like spending $100 billion to build a machine that prints $500 billion bills. The problem? That first $100 billion. Hi, investors, give us $100 billion. For what? To mine invisible gas on the moon for reactors that don't exist yet. But if it works, we'll make $500 billion per ton. Security, please escort this person out.
Remember the space race of the 1960s? USA versus USSR, democracy versus communism, Neil Armstrong versus whoever the Soviets were going to send before their rocket exploded. That was about prestige, flags, and footprints. We came in peace for all mankind and all that hippie stuff. This new space race, it's about money, resources, energy dominance, and everyone's invited to the party. Space Race 1.0, we go to the moon to inspire humanity. Space Race 2.0, we go to the moon to strip mine it for profit. At least we're honest now. Let's meet the players in the great lunar land grab. Player 1, China, the quiet achiever. While everyone else talks, China does. Their strategy is brilliant. Say nothing, do everything. Achievements? First soft landing on far side, 2019. Returned lunar samples, 2020. Planning crewed landing, 2030. Building lunar base, 2035. Full mining operations, 2040. Their secret weapon? They don't have to convince voters or shareholders. The Communist Party says, mine the moon, and boom, they're mining the moon. Democracy. Should we mine the moon? Let's debate for 10 years. China. Already mining, you were saying? Quote from Chinese space officials. The moon's helium-3 will solve Earth's energy crisis for 10,000 years. Not might, not could, will. They've also partnered with Russia to build the International Lunar Research Station, because nothing says trustworthy partnership like China and Russia working together. Player 2, USA, the comeback kid. America's response, the Artemis program, named after Apollo's twin sister because symbolism? The plan, Artemis 1, test flight, done, 2022. Artemis 2, crew around moon, 2025, maybe 2026, probably 2027. Artemis 3, land on moon, 2026, just kidding, 2028, actually 2030. Artemis base camp, permanent base, 2030s or 2040s, eventually. NASA, we're going back to the moon. Public, when? NASA, soon-ish, depends on funding and politics and whether SpaceX delivers. But here's the twist. NASA isn't doing this alone. They've outsourced everything to private companies. SpaceX, building the lander, Starship. Blue Origin, building backup lander because Bezos sued until he got a contract. Lockheed Martin, building the Orion capsule. And Boeing, building the SLS rocket. Only 10 years late and $10 billion over budget. The real power move, the Artemis Accords. It's basically America writing the rules for moon mining and getting other countries to sign on. Signatories? 32 countries. Not signing? China, Russia. Shocking. Player 3, India, the budget disruptor. India's strategy, do everything China does, but for 1/10 the cost. Chandrayaan-3 landed on the moon for $75 million. NASA's coffee budget is probably higher. NASA. Our lunar mission costs $50 billion. India. Ours costs $75 million. Million? With an M? We use PowerPoint instead of fancy animations. Saves money. India's plan. Map helium-3 deposits, in progress, develop extraction technology by 2030, joint ventures with whoever pays, probably USA, undercut everyone's prices, definitely. They're the Walmart of space exploration, and I mean that as a compliment. Player 4, Russia, the declining power. Russia used to be the space power. First satellite, first human in space, first space station. Now,
Luna 25 mission 2023 crashed into the moon. Yeah. Russia, we're back in the space race. Moon. Lol? No. Their strategy now is partnering with China because they can't afford to go alone. It's like the former high school quarterback working for the class nerd who got rich. Player 5. Japan. The tech innovator. Japan's approach: build a technology everyone else needs. They're developing lunar rovers, already working with NASA, resource extraction tech, precision landing systems, and probably giant lunar robots, because Japan. Their strategy is smart. Why compete when you can sell shovels to everyone in the gold rush? You want to mine the moon? Buy our equipment. But you're not mining. Why would we? You're paying us billions for tools. Laughs in Japanese. The billionaires, the wild cards. Elon Musk. SpaceX. Plan: build city on Mars, but mine the moon to pay for it. Capability: can actually deliver. Sanity level: tweets about Dogecoin while building interplanetary spacecraft. Jeff Bezos. Blue Origin. Plan: move heavy industry to space. Capability: has rockets, lawsuits ready. Motto: slow and lawsuity wins the race. Private mining companies. iSpace, Japan, actually has contracts for lunar delivery. Astrobotic, launching first commercial moonlander 2024. Intuitive Machines, NASA contractor, might actually work. Government space agencies will be on the moon by 2030. Billionaires will be there Tuesday. Governments, that's impossible. Billionaires, we don't care. The legal chaos. Here's the fun part. Nobody knows who owns the moon. The Outer Space Treaty of 1967 says, no country can claim the moon. Space is for all mankind. No weapons of mass destruction. What it doesn't say is, can companies claim territory? Who owns resources once extracted? What happens if two countries want the same spot? Can you have regular weapons? Asking for a friend? The moon belongs to no one. Cool. So I can mine it? Well, no. So someone owns it? No. But what?
Look, we didn't think this through in 1967, okay? The Artemis Accords try to establish safety zones around lunar operations. China calls them American colonization. China's proposing their own rules with Russia. America calls them authoritarian space grabbing. Meanwhile, companies are like, while you argue, we'll be mining. The conflict scenarios. Scenario 1. The overlap. 2035, US and Chinese bases set up 10 kilometers apart. Both claim the same helium-3 rich region. Who decides who gets what? Answer: whoever has the bigger space guns. That definitely don't exist, wink. Scenario 2. The sabotage. Country A's mining disrupts Country B's operations. Oops, our excavator accidentally destroyed your solar farm. Oops, our communications laser accidentally blinded your satellite. Space court doesn't exist. Scenario 3. The blockade. One country controls lunar orbit. Nice mining operation. Shame if something happened to your supply rockets. Earth, this is an act of war. Space, prove it.
The moon is for peaceful purposes only. Define peaceful. Not war. Define war. That's what I thought.
Let's talk money. Stupid, absurd, civilization-changing amounts of money. Current global energy market, $10 trillion per year. Helium-3 fusion market potential, $100 trillion per year. First mover advantage, priceless. Actually, probably $1 quadrillion. Here's how the economics breaks down. The current energy disaster. Right now, humanity spends $5 trillion per year on fossil fuels, $2 trillion per year on renewable infrastructure, $1 trillion per year on nuclear, $2 trillion per year on grid infrastructure, countless trillions on wars over energy resources, total $10+ trillion per year just to keep the lights on. We spend 10% of global GDP on energy. That seems like a lot. It gets worse. Most of it literally goes up in smoke. And it's killing the planet. Great system we've built here. The Helium-3 revolution. Now imagine, one fusion reactor can power a city. No carbon emissions, no radioactive waste, no risk of meltdown. Fuel cost? Nearly zero. After initial investment. The math is, 100 tons of helium-3 equal all global electricity needs. Mining cost? Around $50 billion per year. Current electricity cost? Around $3 trillion per year. Savings? $2.95 trillion. That's $2.95 trillion every year. That's enough to end world hunger, cost $40 billion per year, and homelessness globally, $20 billion per year, provide clean water to everyone, $10 billion per year, fund NASA's entire budget 100 times over, and still have $2.5 trillion left over for yacht money. But will we use it to solve humanity's problems? New yacht designs are looking great this year. Right. The investment race. Current investments in lunar and helium-3 infrastructure? China, $10+ billion. Admitted, probably 3 times that. USA, $93 billion. Artemis program through 2025. Private companies, $5+ billion. India, $2 billion. Europe, €3 billion. Russia, whatever lint they found in Putin's couch. But here's the thing. Whoever gets there first doesn't just win the energy market. They control global energy prices, industrial competitiveness, military superiority, fusion rockets, anyone? Space colonization, helium-3-powered spacecraft, basically everything. So one country could control all future energy? Theoretically, that won't cause any problems. None whatsoever. When has energy monopoly ever caused issues? The disruption cascade. When helium-3 fusion comes online, entire industries collapse overnight. Dead. Coal mining, 500,000 jobs, $500 billion industry. Oil and gas extraction, 6 million jobs, $3 trillion industry. Traditional nuclear, 500,000 jobs, $500 billion industry. Power transmission, 2 million jobs, no need for long-distance grids. Born, lunar mining, 100,000 jobs. Fusion plant operators, 500,000 jobs. Space logistics, 1 million jobs. Energy abundance industries, millions. Countries that depend on fossil fuel exports, they're screwed. Saudi Arabia, GDP drops 40%. Russia, GDP drops 30%. Venezuela, GDP drops to, does negative GDP exist? Norway, they'll be fine. They save their oil money like adults. Meanwhile, countries with space programs become the new energy superpowers. USA, we have SpaceX. China, we have determination. India, we have cost efficiency. Luxembourg, we have space laws. The price wars. Here's where it gets interesting. Helium-3 pricing. Current Earth price? $30,000 per gram,
$30 billion per ton. Why? Because we only have 300 kilograms total. Projected price with Lunar mining? Year 1, $10 billion per ton, recoup investment. Year 5, $1 billion per ton, competition kicks in. Year 10, $100 million per ton, mass production. Year 20, $10 million per ton, commodity pricing. So it goes from priceless to cheap? Welcome to economics. Won't that crash the market? Only the fossil fuel market. Oh no! Anyway, the GDP explosion. With essentially free energy, global GDP could increase 10 times in 50 years. Manufacturing costs drop 90%. Transportation becomes trivial. Desalination solves the water crisis. Vertical farms feed everyone. Climate control becomes affordable. Space colonization becomes feasible. We're talking about going from a $100 trillion global economy to a $1 quadrillion economy by 2100. But only if we don't kill each other fighting over moon territory first.
So let's say we pull this off. It's 2040. Helium-3 mining is operational, fusion reactors are humming along nicely, and energy is basically free. What does that world actually look like? The environmental renaissance. First, the obvious. Climate change becomes a solved problem. No more fossil fuels equals no more emissions. Cheap energy equals we can actively remove CO2. Desalination equals fresh water for everyone. Vertical farms equals reforest the planet. Fusion rockets equals no more chemical rocket pollution. We solved climate change. Great! What's the catch? Well, we had to strip mine the moon. The uninhabited, lifeless moon? Yes, I'm okay with this. Within 50 years, Earth could be greener than before the Industrial Revolution. Except, with cities and internet and stuff. The social revolution. Free energy means poverty becomes a choice, not a circumstance. Education accessible globally. Internet everywhere. Healthcare revolutionized. AI plus unlimited compute power. Transportation, basically free, fusion-powered everything. Housing costs plummet. Robots and energy equals cheap construction. But here's the dark side. What happens to human purpose when machines do everything? Nobody needs to work anymore. Yay! So what do we do all day? Anyone? TikTok? Dear God. The space explosion. With helium-3 fusion, space travel becomes actually practical. Fusion rockets? Mars in 30 days instead of 9 months. Lunar cities? Power is solved. Asteroid mining? Now economically feasible. Interstellar probes can get us to 10% light speed. Dyson sphere? Why not? We've got the energy. By 2100, 1 million people living on Moon. 100,000 on Mars. 10,000 in space stations. 1 probe heading to Alpha Centauri. And flat earthers still convinced it's all fake. The military revolution. Here's the scary part. Fusion changes warfare completely. With fusion-powered lasers, actual Death Star stuff, fusion rockets, ICMBs that arrive in minutes, not hours, fusion-powered railguns, kinetic weapons from orbit, energy shields, plasma windows are already real, and fusion bombs. Makes H-bombs look like firecrackers. We've created unlimited clean energy. Wonderful. Let's weaponize it. That's not what we meant. Weaponize it. The country that controls helium-3 basically becomes invincible, which is why everyone's racing to the moon. The biological revolution. Unlimited energy means unlimited computational power for biological research. Protein folding solved. Means most diseases are cured. Aging reversed. Energy-intensive cellular repair. Designer organisms need lots of compute power. Brain uploading theoretically possible with enough energy. actual food replicators, molecular assembly. We could literally become a different species within 100 years. We can live forever. On the moon? Well, Earth might be full of immortals, so... Moon retirement home. Got it. The philosophical crisis. When energy is free and robots do everything, fundamental questions arise. What is human purpose? What has value when material goods are free? Who decides who gets to be immortal? What happens when we run out of helium-3 in 10,000 years? Is this still capitalism if money doesn't matter? We might solve every material problem only to face an existential crisis that makes current problems look quaint. We solved everything. Great. Now what? I don't know. Want to mine another moon? Sure. Why not? The timeline. Here's my prediction for what actually happens. 2024 to 2030, the rush. Multiple lunar missions launch, first private landing on moon, helium-3 deposits mapped, mining technology tested, and at least one spectacular failure. 2030 to 2035, the establishment. First permanent lunar base, small-scale helium-3 extraction, first fusion reactor using lunar helium-3, economic panic in fossil fuel markets, and space military forces established. 2035 to 2040, the transformation. Commercial helium-3 mining begins. Fusion plants start replacing fossil fuels, energy prices collapse, massive economic disruption, and first resource conflict on the moon. 2040 to 2050, the new normal. Fusion powers 50% of Earth. Lunar population exceeds 10,000. Mars colonization accelerated. Traditional economies restructured. And post-scarcity society emerging. 2050 plus, the unknown. Humanity fundamentally transformed. Earth-Moon economy established, expansion to entire solar system, first interstellar missions, and probably some weird stuff we can't imagine.
So there you have it. While you've been worrying about your electricity bill, the world's superpowers are quietly racing to mine invisible gas from moon dust that could power civilization for 10,000 years. This isn't science fiction. The rockets are launching now. The technology exists now. The only question is who gets there first and whether they share, or whether we end up with the first off-world war. Helium-3 could be humanity's salvation. Unlimited clean energy, end of poverty, expansion into space, solution to climate change, evolution into a Type 1 civilization. Or it could be our doom. Resource wars in space, unprecedented wealth inequality, weaponization of fusion, loss of human purpose, the moon looking like Swiss cheese. Either way, it's gonna be interesting. And by interesting, I mean either utopian or apocalyptic, with very little middle ground. Your grandchildren will either thank us for mining the moon or curse us for starting the lunar wars. There's really no in-between here. The race is on, the stakes are everything, and most people have no idea it's even happening. Welcome to the future. It's powered by moon dust, controlled by whoever gets there first, and coming whether we're ready or not. Thanks for spending this hour contemplating humanity's energy salvation and/or doom with me. If you enjoyed learning about our impending lunar strip mining operation, hit subscribe and like the video. Next up, something even more interesting. Spoiler, it's not for the view. Until then, look up at the moon tonight and remember, that's not just a celestial body. That's a gas station worth $500 billion per ton, and everyone wants the keys. Sweet dreams, future lunar colonists.